Okay, now we're going to look at a scene where we have a third-person view with this ball that moves by rotation. So yeah, the rotation force here. Okay, so I won't go into how to create the third-person camera because I'm not sure how this works. I just used ChatGPT for that. So we have the camera with a script that gives us this third-person view, and also the camera follows the ball. Because I tried to place it as a child of the sphere, but the sphere rotates, so it will move the camera. So you cannot make it a child of the sphere. You have to keep it separate and make it follow the sphere. Okay, so let's look at how we move the sphere. So once you have that third person controller for the camera, you can do the movement. So let's see. To move it, we want to know what's the forward um, direction, but relative to the camera. But you will notice that sometimes the camera looks towards the ground and sometimes it looks towards the sky. So if you get that forward of the camera, it will either be towards the ground or towards the sky, and we don't want that. We want the forward to be parallel to the ground. So to do this, we have a separate object, an empty object, and what we do is we copy the rotation of the camera here, but we put 0 on the X rotation. So that means that the forward will now be parallel to the ground. So that's what we do to get the forward of the forward relative to the camera rotation. So what we do, we get the horizontal and vertical axis every frame. So this will let us know if WASD are pressed. So horizontal is for A and D and vertical is for W and S. So the horizontal axis will be for left-right movement and vertical will be for forward and backwards movement. So like I said, we do this to that empty object to get the rotation of the camera, but make the forward parallel to the floor. But when we rotate it, this will not work because let me show you. Actually, I have model summary here. Yes. So this is our ball here, okay, and you can see those are the, you can consider those as the z-axis and the x-axis. So if we get the forward relative to the, you can imagine this as the forward relative to the camera. Okay. If we do this, when we press forward, so the W or backwards, it will move left and right instead because let me see. Let me actually put something on that so we can see the rotation. There's a cube on that. Okay, 1 second. Okay, so we can see the rotation of this. Okay, so let's see. So you see, when if you we rotate it using the forward of that camera view, it will rotate like this when we when we go forward or backwards. We want to rotate the using the Z axis. Like, sorry, not the Z, but yes, that want to use the other axis, right? So to do that, we actually add 90 degrees to that Y rotation of the cam to achieve this. Okay, so once we have that, the move direction would be, once we have that rotation, the move direction will be the horizontal axis. So this will let us know if A or D are pressed, multiplied by the right relative to that camera transform that we created, and then the same for the vertical axis. The vertical axis multiplied by the forward relative to that camera transform. Okay, and then for the jump is very simple. We just change the linear velocity on the y-axis, and for the movement we add the rotational force, so torque here. We add torque, and then this is the direction, and we multiply by the move speed. But I want to explain this one more time because it is not very simple to understand how why do we add 90 degrees here to the camera transform. Okay, the idea is when we get the camera transform and then it is the forward of that camera transform is parallel to the floor, to the ground. If we rotate using that, we rotate around this blue axis here. Okay, so let's see. So we rotate it like that when we press forward. Okay, so that's why we rotate it by 90 degrees the camera transform. Okay, thank you very much.